Every junior dev sees this problem once. And most of them write it twice as slow as they need to. The fix is one line. But only if you understand the first version first. Concatenation of array. Part 1. The brute force. Companies that actually ask this: Google, 4 times on record. Meta, Amazon, Adobe, OpenAI, all on record too. This is a real interview warm-up, not a toy problem. Here's the problem. You're given an array of integers. Your job is to build a new array that's twice as long, where the first half copies the original, and the second half copies it again. 2 copies, side by side, in one output. Said differently, copy the input into the first half, then copy it into the second half. That's it. Example 1. The input is 1, 4, 1, 2. The output is those 4 numbers, then those 4 numbers again. Constraints matter. The array always has at least one element, never more than 1,000. Values are small positive integers. 2 things this tells us. First, there's no empty array case to worry about. Second, nothing can overflow. The constraints already protected you. Pause the video for 10 seconds. How would you solve this, without any tricks? Describe the steps to a friend, out loud. Got something? Good. Now compare with mine. Think of a photocopier. You feed in 1 page. It spits out 2 copies, stapled together in order. The output tray is your output array, fixed size, ready to receive both passes. Before any code, here's the whole algorithm as a flowchart. Top to bottom. First, find the length of the input. Second, make a new array that's twice as long. Third, run a loop to fill the first half. Fourth, run another loop to fill the second half. Fifth, return the result. 5 boxes. That's the whole video. Quick check. If your input has 5 elements, how long should the output be? Pause, and answer in your head. 3, 2, 1, 10. Twice the input length. Always. Step 1. Make the output array. In JavaScript, we use the new array constructor, with twice the input length. Arrays could resize on the fly, but it's faster and safer to lock the length up front. Here, we know it exactly. Step 2. The instinct. Copy the input over. Then copy it again. 2 separate loops. The first loop fills the first half, positions 0 up to n-1. The second loop fills the second half, positions n up to 2n-1. In pseudocode, first, get the length, call it n. Second, make a new array of size 2n. Third, the first loop, for every position from 0 to n, copy the input into the output at the same position. Fourth, the second loop, same iteration, but write to the position offset by n. That's the whole algorithm. Now the JavaScript. The function is called getConcatenation. It takes 1 parameter, the input array. No type annotations. This is plain JavaScript. Inside the function, 2 setup lines. First, store the input length in a variable named n. Second, create the output array with size 2 times n. Memory is locked in. In our example, that's 8 slots. The first loop. Iterate from position 0 up to n. At each step, copy the input element at the current position into the output at the same position. A straight copy, slot by slot. The second loop. Same iteration. I goes from 0 up to n. But the body is different. We write to the position offset by n, while still reading from the same position I. Read that twice. Same read, different write. This is the only line that matters in the whole video. Why the offset works. Picture 3 lanes. Top. The counter I, running 0 up to n-1. Middle. We read the input at position I. Bottom. We write to the output at position I offset by n. The offset is a shift. It lands us in the right slot of the second half, every single iteration. Let's trace it on example 1. The input is 1, 4, 1, 2. So n is 4. The output starts as an array of 8 blank slots. Watch the cells fill. First loop runs. When the counter is 0, the output at position 0 becomes 1. When the counter is 1, the output at position 1 becomes 4. Position 2 becomes 1. Position 3 becomes 2. First half is filled. Second loop starts. The counter resets to 0. But now we write to the offset position, which is position 4. Same value, 1. When the counter is 1, position 5 gets a 4. Counter 2, position 6 gets a 1. Counter 3, position 7 gets a 2. Every iteration writes into the second half. Final result: 1, 4, 1, 2, 1, 4, 1, 2. Matches the expected output. The algorithm is correct. Time complexity: 2 loops, each running n times. Total: 2n operations. We drop the constant. The answer is big O of n. Linear time. Space complexity: the output holds 2n elements. But output usually doesn't count toward auxiliary space, only extra storage does. So our auxiliary space is constant. Big O of 1. If you count the output 2, the total is O of n. Trap 1, off by 1. If your loop condition accidentally says I less than 2n in the first loop, you'll read past the end of the input on the second pass. JavaScript returns undefined, silently. Your output ends up with undefined values inside it. JavaScript is meaner than Java here. Java would have thrown an exception. JS just lets the bug ship. Catch this in your head, before your tests do. Trap 2, sneakier. In the second loop, you forget the offset. You write to the same position I, instead of the offset position. The second loop silently overwrites the first half. The code runs without errors and produces wrong output. Half your test cases pass. Half fail. Hard to spot. Remember the photocopier? 2 passes, 1 stapled output. That's literally what this code does. 2 loops, 1 output array. The mental model and the code agree. That's how you know you actually understand it. This works. It's correct. It's clean. But 2 passes through the same data is 1 too many. There's a 1-loop version using modulo. And it's the kind of trick you'll use again, across at least a dozen array problems. That's part 2. Quick recap. 1. Make the output array, size 2n. 2. First loop copies the input into the first half. 3. Second loop copies the input into the second half, using the offset trick. 4. Time is O of n. Auxiliary space is O of 1. That's the whole brute force. If this helped, part 2, the modulo trick, drops next. Subscribe so you don't miss it.